Hello, welcome to today's video. We're finding the derivative of inverse trigonometric functions, and this video is for a proof, and in the follow-up video we will do some examples. So let's get started. Let's start with y equals inverse sine x. Okay, well if that's the case, and I know x is sine y. Now we want to do that because I can find dx dy pretty easily because I know sine, the derivative is cosine, and let's remember what we did in the last video with the inverse. So then dy dx is 1 over that. Okay, but I don't want my derivative in terms of y. I want my derivative in terms of x. Now our trig identity, we remember this one. Sine squared theta plus cosine squared theta equals 1. So I want to get cosine theta by itself. So cosine squared y will be 1 minus sine squared y, and then we can take the root of both sides. Okay, and then that's handy because I can just directly substitute that. So dy dx is equal to 1 over root 1 minus sine squared y. Alright, but still not in terms of x. Now let's just have a look back up here. I can see x equals sine y. So x squared is sine squared y. So that's handy because I can now just make that substitution there. So final result is the derivative of inverse sine x is 1 over 1 minus x squared. Okay, this time y equals inverse cosine x, very similar to the last one. So the x is cosine y, and I can easily find dx dy, that'll be negative sine y, and then I can do the inverse of that, and I've got negative 1 over sine y. So all pretty much the same so far, and then don't forget our trig identity that we had from the last question, or last proof, and let's skip a little bit this time so I can say sine y is root 1 minus cosine squared y. So same deal as last time, I can make that substitution there. So dy dx is negative 1 over root 1 minus cosine squared y. So remember what we did here in the last one. I can use this part here. X is cosine y, so x squared is cosine squared y, and I can substitute that in there. So my final result is the derivative of inverse cosine x is negative 1 over root 1 minus x squared. Next one is y equals inverse tan x. So we kind of know the drill by now. So x is equal to tan y, and I can find dx dy easily, which is tan differentiates to secant squared. Alrighty, so from here we then found dy dx will be 1 over sec squared y. Alright, now here we used our trig identity. Sine squared theta plus cosine squared theta equals 1. But I don't have that. What I want to do here is, remember I can get those other identities. This one I want to divide everything by cosine squared, because when I do that, then I end up with tan squared theta plus 1 equals sec squared theta. Now I want to do that because I can substitute that for sec squared. So dy dx is 1 over tan squared y plus 1, and then we can see what we had up here. X equals tan y, so x squared is tan squared y. So final thing, our final result, the derivative of inverse tan x is 1 over x squared plus 1. Okay, and we can also find the derivative of our inverse trig functions if we have them in a form like this. So inverse sine x over a. I'll do the one for sine, but cosine and tan, they all follow the same pattern. So see if you could go back and prove them yourself. So how do we do this? Well, x over a will be sine y, and then x will be equal to a sine y. So now I can find dx dy. That'll be a cosine y. So my dy dx is 1 over a cosine y. All right, now here we've used our trig identity a few times already, so I'm just going to make that substitution. Go back earlier in the video if you want to see what I'm doing here. This is a root. This will be 1 minus sine squared y. Okay. Now here's where it gets a little bit different because I know this. Okay, so if I want to get sine squared, that's squaring both sides, so I'll end up with x squared over a squared equals sine squared y. So this will be 1 over a root 1 minus x squared over a squared, and then this looks a little bit ugly. We can simplify it a little bit. If I want to bring this a into this root, well, that would become a squared. So if I multiply the 1 and this term by a squared, then this term here, the a squared, will cancel. So my final result is, just make sure I'm on black, there we go, dx of inverse sine of x over a is equal to 1 over root a squared minus x squared. So you can do the same for inverse cosine and do the same for inverse tan. And that's it for the derivative of inverse sine x, inverse cosine x, and inverse tan x. On your reference sheet, this is what you will see, and might look a little bit different, but it's actually the same, and it's simply just a generalized chain rule. So you can see this is inverse sine of a function of x, and you can see that you've got the derivative of that function and the function under there. So you can see exactly what's happening. So always want to be familiar with what you're going to see in your exam, and this is it. And there we go for the proof of the derivative of inverse trigonometric functions. I'll link the next video in the description for some examples. Please hit the sub button and hit the like button, and I will see you in the next one.